Hello, today we will be presenting our project on movie recommender system using content-based and collaborative filtering. A recommender system is a system that seeks to predict the rating or preference a user would give to an item. Recommender systems usually make use of either or both collaborative filtering and content-based filtering. Collaborative filtering approaches build a model from a user's past behavior as well as similar decisions made by other users. This model is then used to predict items that the user may have an interest in. The content-based filtering approaches utilize a series of discrete pre-tagged characteristics of an item in order to recommend additional items with similar properties. Talking more about collaborative filtering, it only needs users' historical preference on a set of items. Because it's based on historical data, the core assumption here is that the users who have agreed in the past tend to also agree in the future. The one problem is that it requires a large amount of information about a user to make accurate recommendations, also known as a cold start problem, and is common in collaborative filtering systems. While content-based filtering needs very little information to start, it is far more limited in scope. It can only make recommendations that are similar to the original seed. Content-based recommenders treat recommendation as a user-specific classification problem and learn a classifier for the user's likes and dislikes based on the product features. In this system, keywords are used to describe the items and a user profile is built to indicate the type of item this user likes. The dataset we've used for this project is called the MovieLens dataset. This dataset comes in multiple sizes and we have experimented with a small dataset which is 100K and the 20 million dataset. The dataset consists of multiple CSV files, each containing different information about a set of movies. The movies.csv contains titles and genres for movies, whereas the ratings.csv contains users and their ratings on multiple movies. There is also tags.csv which contains tags associated with a movie, and links.csv which gives IMDb links to the movies. We chose mean absolute error and root mean squared error as our metrics to verify the performance of our system with respect to standard algorithms and libraries. So, starting with the actual implementation, initially we tried to use a non-deep learning method to implement collaborative filtering, which is by using the simple stochastic gradient descent as learning algorithm. We used the SGD learning algorithm to create latent user and movie feature matrices based on loss between the two matrices. By this we obtained a final RMSE value of 0.983. Next, we tried a deep learning approach for the same method. We used a deep learning model instead of the SGD algorithm. We went about creating the deep learning model as follows. Firstly, we preprocessed the data to remove inconsistencies and garbage values. Then, we split the data into training and testing datasets by making a 80-20 split using the sklearn's train test split library. We then created our model using embedding layers for the movie matrix and the user matrix, and then we experimented with a bunch of layers to get the best combination. Next, we also tuned the hyperparameters. After finding the best possible configuration of hyperparameters, we trained the model and used the model for predictions. This is the summary of our model. We experimented with different values of number of hidden layers, dropout values, optimizers, and learning rates, we found out that the combination of one hidden layer with 50 nodes, 20% dropout, Adam optimizer, 0.001 learning rate, and 100 epochs gives the best values of the RMSE value, which was 0.81. Here we can see the top 15 recommended movies for the user with user ID as 1. Next, we move on to the second popular method for movie recommendation, which is the content-based filtering. We went about creating the autoencoder model as follows. We pre-processed the data to remove inconsistencies and garbage values. We then split the data into train and test, making 80-20 split. Then we created an autoencoder model which gives encodings of the TF-IDF vectors of the user ratings data. We then tuned the hyperparameters, trained the model, and used the model to make predictions. After the autoencoder converges, we obtain encoded word embeddings, and then we compute the cosine similarity within these encoded embeddings. We then query this cosine similarity matrix with the movie ID as per the dataset and give back top 20 movies for a given user based on the ratings. In theory, using embeddings of one movie to cosine with all the other movie embeddings to create a similarity matrix should return movies similar from the input movie. We evaluate the top 20 movies returned for the movies Toy Story and GoldenEye. We noticed that a considerable number of movies adhere to Toy Story's adventure, comedy, and fantasy genres. This is a comparison of the three of our algorithms with a bunch of other benchmark algorithms trained on MovieLens data. We can see that our deep learning collaborative approach model has the best RMSE value of 0.817. We can see that the deep learning algorithms perform better than the original algorithms, but it takes a long time to train, and the deep learning algorithm is also scalable to a larger data set without greatly affecting the RMSE value. That was our project on movie recommender systems. Thank you.